This conference will now be recorded.
Okay, this conference is now recorded. Did everybody hear that? Like they did.
We did, yes.
Okay, evening, ladies. I trust you can hear me okay. You can put your arm up if you like, but welcome to the first Thames Valley PWI talk of 2021, in which I'll be looking at the history and development of the railways in the Auckland area of New Zealand. Okay, please note that the material I've used in my presentation is mainly from the public domain, but it's also from personal experience working on the railways when I was in New Zealand during 2014, just before the electrification system started, and more recently in 2019 and before COVID set in. So this shouldn't be taken as the verbatim from Auckland Transport or Kiwi Rail. It's freely on the public domain. Okay, in discussing the history and development of the railways in Auckland, I'm going to be setting the scene by outlining the existing topography and the changes to the landscape before looking at the overall railway development. And the timeline from the horse-drawn tramways in the early stages to electric trams and the present railway. I'm also going to be looking at the governance of the railway and how it changed hands from it became a private company then until it formed Auckland Transport a few years back. We're then going to look at the patronage changes over the years, which have changed considerably. And then after reviewing the initial railways, initial tramways that existed, I'll then look at the main railway network and the infrastructure, including the typical infrastructure, track signalling, electrification, rolling stock, etc. And then look at a few projects that are in the pipeline, notably the City Rail Link, which is a big project ongoing at the moment in Auckland, possible light rail projects coming up, and the future for high-speed rail. Okay, before we go into the details, a few words about the Auckland area. I'm not sure everybody's been to Auckland, and I hope you all know where it is, but in case you don't, it's the northwest part of the North Island. It is the most populous urban area in the country. It has an urban population of about 1.5 million. And the region includes the outlying rural areas and the islands of the Hauraki Gulf. Can you see my pointer? Not sure if you can see the pointer, but the Hauraki Gulf on the right-hand map, you can see where the Hauraki Gulf is. So including the islands, the population is about 1.7 million.
Just going to come on, Matthew. I can't see your pointer myself. Are you pointing at the main slide or at your presenter view slide?
I'm pointing at the main slide.
Okay.
Can you see it now?
Yeah, we can see it now.
Okay. So the Hauraki Gulf is where my pointer is now. So basically, the lines between the Hauraki Gulf to the east extends to the Hunau Ranges, and then to the Manukau Harbour, which is pointing down here just south of the word Auckland in the brown, and to the southwest, and the Waitakere Ranges in the west. The surrounding hills are surrounded by rainforest. The landscape has 53 dormant volcanoes in the Auckland area, which is quite incredible. Central part of the urban area occupies a narrow isthmus between Manukau Harbour, down here again, and on the Tasman Sea, which is the Tasman Sea here, and basically the Pacific. So it's one of the few cities in the world to have a harbour on two separate major bodies of water. First settled by the Maori around 1350, and after a British colony was established in 1840, William Hobson, the then governor of New Zealand, chose the area as his new capital, and he named the area after the Earl of Auckland, George Eden. He was the first British Lord of the Admiralty. Auckland was replaced as the capital in 1865 by Wellington, partly because Wellington's halfway between north and south, so it was felt that Auckland was too far north. But however, the city continued to grow, initially because of the ports and the logging and the gold mining in the hinterland, from dairy farming, and throughout most of the history, it's been the nation's largest city. today Auckland's central business district is New Zealand's leading economic hub. So the brown area, let's go back to the map, the brown area, as I'm highlighting on the map, is the main part that I'm going to discuss about the railways. Okay, this map shows some of the geology of the Auckland area. As you can see, New Zealand lies on a junction of the Australian and the Pacific plate, running the junction, the tectonic plates runs between North Island, South Island, and North Island is just on the Australian plate. They're being pushed towards each other, but with different results in different parts of New Zealand. To the east of the North Island is a subduction zone where the Pacific plate is diving underneath the Australian plate at about 45 millimeters a year. So you have some pretty vicious movements. Okay, slide. Auckland is renowned for its volcanoes, and on the map on the left you can see the number up to 53. 53 is at the bottom here. The map on the right was produced in 1859 and shows the extinct volcanoes in the area. One notable volcano is that which formed Rangitoto Island around 600 years ago, and that's this big island to the north here. Collapse that screen a bit. It's this big island to the north here, which is almost the size of the centre of Auckland. That is Rangitoto Island, and that was formed 600 years ago. So it's pretty new. And it's number 7 on the left-hand map, so it's big area on the left-hand map here. Okay, let's go to next slide. This is Mount Eden, which is just to the south of central Auckland, and it lies to the west. Mount Eden Station, which we'll come up to a bit later on when we're talking about the City Rail link, is to the west of this volcano. So you can see in the distance, there's Auckland in the distance, and you've got the Bay of Islands. You've got lots of islands in the distance as well, and big Mount Eden. Mount Eden is nowhere near the biggest, but it looks pretty big from there, and it's big from when you're on the top of it. It's also the home of New Zealand Rugby, Eden Park, if anybody knows your rugby. Okay, the Auckland Isthmus, the area around Auckland, has witnessed about a millennium of Maori occupation and use. Volcanic soils of the isthmus provide rich cultivating soils. And you can see this map sets the scene showing the area of Auckland where the first railways were developed. So from the outset, the bay to the east of Point Britomart, which is I'm pointing to now, Point Britomart Point. This was the commercial centre of the new settlement, and it was given the name of Commercial Bay. And in 1841, the General Surveyor drew up a plan for the new city, which created deep water berths for visiting ships. By the early 1860s, improvements had been made to the port, but you can see from this that you can see where the actual original shoreline was in red for the old bay, before any development. And so that development has only occurred since 1840. And Britomart Point is where the terminus station is. And in this area that I'm highlighting here, there's a lot of railways that have been built in there since 1840. The Britomart is an unusual name for a station. It got its name from HMS Britomart, the crew of which undertook a detailed survey of the harbour. Britomart Point is the approximate location of the railway terminus. The name actually comes from the Greek goddess of mountains and hunting, which is appropriate for the volcanic area. Okay, so let's make a start on the governance of the railways. New Zealand Railway Network was constructed by provisional governments from about 1863, built to Irish gauge, 1600 gauge, or 4 for 8.5. From 1870, central government adopted national gauge of 3 for 6. 1067 or 1068, depending on who you believe. And the first railways between Auckland and Onehunga opened in 1873. And it was built by a company called John Brogden and Sons, who were from England. They brought them over from England to build the railway, and they became what was known as Brogden Navvies. There are a number of private companies in New Zealand, one of which was called the Thames Valley Railway Company. This is nice to know, because the Thames Valley is on this map. The Thames Valley is in this area, just in here by the Coromandel Peninsula. There's the River Thames. There's a lot of English names in New Zealand, as you'd expect. So there was the New Zealand Midland, the Waimo Plains, and the Thames Valley Railway Company. The main railway line between along the North Island was the North Island Main Trunk, opened in 1908 after 23 years of construction. And then it was until 1982 that New Zealand Railways Corporation was formed. Then it was privatised in 93. Then the new owners were adopted the name Transrail. And then the government purchased the Auckland area from Transrail for $81 million. And then later on, a company called Toll Holdings from Australia, they took over Transrail in 2004 and sold the track back to the government for $1. And then the actual track started to run down, and it was in a poor state of repair. And in 2008, the government bought it back. And then in 2010, Auckland Transport was formed with a company called Transdev operating suburban services in Auckland. So that's about New Zealand. Let's have a look about the actual timeline for the main timeline for Auckland Railways. As I said earlier, in 1853, the first train was from North Island, from Auckland to Onehunga in 1873. Horse tramways started in 1884, and then they finished in 1901, and electric railway started. Electric tramway service was started with the only first coast-to-coast tramway system. And then the idea of an underground railway from the Northern Line City was proposed in 1923, and then a new central railway station was opened at what was called Beach Road near the Strand in 1927. We'll have a look at a map in a minute about that. And that became Britomart Station. In 1968, electrified rail and underground loop was proposed. And then later on in 1983, they were considering abolishing the railway system completely. Again, in 2003, Britomart Station opened, bringing rail back into the heart of the city for the first time in 70 years. And this was a terminus station, which had all sorts of problems as a result of that. 2004, the Auckland Regional Transport Authority was formed, and that was de-established in 2010. But in 2007, it was announced that Auckland Railways would be electrified. And took until 2014 for the first electric trains to operate on the Onehunga line, nearly a century after electric trains were first proposed. So it took a long time. So let's go back to the start. The Onehunga branch was a railway from Britomart to the south, 23 kilometres, part of the first government-funded railways in New Zealand. The Auckland and Drury Railway Act of 1863 was passed by Parliament, and it was quoted to enable the Superintendent of the Province of Auckland to construct a railway between the towns of Auckland and Drury with a branch to Onehunga in the said province. So this was constructed initially in using 4x8.5, 1435 gauge in 1865, but because of lack of funds and disputes, there was a problem with the contractor, and construction stalled 2 years later in 1867. Construction then resumed again in 1872 based on the Prime Minister Vogel's plan to regenerate the railways, but it was the new gauge of 1067, 3/6. The line was then mothballed in 1973 because of the rundown of the railways. only to reopen again in 2010 for freight running, for electric train running. And because of that, patronage on the line quickly grew to respectable levels, and there were 1,200 passengers a day in mid-2011, which far exceeded computer transport modelling, which predicted 340 by 2016. So it's been a big success, and this photograph shows the first day of opening of Onehunga railway station. Okay, let's have a look at the public transport patronage in the Auckland area. This chart shows the patronage from the 1920s to 2015, just before electrification. Figures from the 1920s to the 1950s show a massive volume of traffic from tramways, in particular, with smaller numbers of ferry and railway service. So this great big mountain of traffic is tramways, very small amount of railway, and probably the heyday of the ferry systems in that era. The period between the 50s and the 70s, the 1970s, was when the trolleybus system was in use, and that came and went. But since the 1950s, there's been a big surge in bus transport. Certainly since the late 1990s, there's been a very big surge in bus transport, from 30 million up to 90 million trips, and a similar surge in rail transport because of electrification, and because since Auckland Transport came into being and up to electrification, and I'll show you some more charts later that show it's even more in the last few years. Okay, let's look at tramways. Brief look at the tramway system. This map's a bit busy, but this shows the 72 kilometres of tramway that were in use in Auckland. Horse-drawn trams, there's a little chart at the bottom here with the horse tramways. They basically were 2 4×8.5 gauge, 1435 millimetres, all scrapped in 1901, but they operated in Auckland from 1884. After which, in 1902, the Auckland Electric Tram Company system was officially opened in November 1902. This company started as a private company before being acquired by Auckland City Council, and the tram network enabled and shaped much of Auckland's growth throughout the early 20th century. As I said, with a length of 72 kilometres, the system was very well utilised, with usage peaking at over 120 million boardings during the Second World War. And that was a time when Auckland's population was under 500,000 at the time. So that's quite a considerable use of tramways. As can be seen, the majority of tramways had a track gauge of 1435. There is a particular tramway which is in the bottom left of this this map, and it's also, if I'm shown on the, if you can look at my cursor, it's in the top left-hand corner of the map, and that is the Western Springs tramway, which had mixed gauge of 1219 or 4 foot, 1219 and 1435. That's now part of the Museum of Transport. Okay. So this was the first horse-drawn tram in 1885. Nice little vehicle, took 30 people. Looks like it could be a little bit cramped for 30 people. Gauge was 1435. Okay, and a general view from a picture poster card I have, but this is a view of the tramways from 1939, so that shows a lot of use of tramways. This was when, at the time, it had 80 million passengers a year in 1939, but it increased to 120 as the maximum. As I say, the Auckland Electric Tram Company was officially opened in 1902. Public services commenced November 1902 and continued to December 1956, with services running from downtown by Central Post Office, across to Onehunga, which is further south, south here to Onehunga on the Manukau Harbour. And as I said before, it had the world's only coast-to-coast tramway system. This is a couple of photographs of the existing trams. There are only 2 tram services now in Auckland. There are 2 existing. I know I said the main trams went out of use in 1956, but they've kept 2 have been kept. The Western Springs Tramway, which is the tramway on the left, which is dual gauge, and that runs between the 2 sites of the what's called MOTAT. If you look on the top of the tram, it's MOTAT. That's the Museum of Transport and Technology, and they have quite a few trams on their site. It's about and the other tram, the nice red tram on the right, it's that used to run on the Wynyard Loop. The Wynyard Quarter is basically the up-and-coming sailing part of town where the America's Cup is due to run next year, if subject to COVID different issues. So the Wynyard Quarter is very gentrified. It's a closed circuit to downtown Auckland. The system was opened in 2011, prior to the 2011 Rugby World Cup, but it's closed a number of times while the streets have been gentrified and while buildings have been put in place, and it's had to be realigned and opened and closed and opened again. It's closed a number of times around the Wynyard Quarter, which has involved re-leveling the roads. However, in 2018, Auckland councillors have voted to reinstate the full loop and have the tram running for the 2021 America's Cup. Whether that's not in use at the moment, but hopefully it will be in use by next year when the America's Cup comes to Auckland in March, I believe. Okay, let's have a look at the main Auckland network. Auckland's network is basically is all 3'6" gauge, 106.7 millimeters, and it divided up into the following lines. The southern line runs from Britomart, which is this little stub point here. It says Ponsonby, Britomart is in here, down to Papakura and Pukekohe. The eastern line is from Britomart to Manukau. The western line is Britomart to eastern line to Manukau around here. The western line is to Henderson and then on to Newmarket to Swanson. Newmarket is this junction in here, which is a very difficult junction. And the Onehunga branch is this little branch line in here, which was mothballed and then I said reopened in 2010. The Manukau branch in here, as I'm pointing to, was a new line, brand new line, opened in 2012. This is a bit more detailed single line diagram, so I'm not sure how easy it is to read on your screens, but with Britomart at the top, so the Britomart terminus station is at the top. Pukekohe is to the south, this is Pukekohe, and Swanson is to the left here. And we have the main depot for the electrified fleet is here at Wiri. There's the section between what I'm pointing to here, the section between Papakura here and Pukekohe is still diesel, waiting to be electrified. As I say, Swanson's to the left, to the west. Britomart is a stub terminus platform, say station, and the EMU depot is in Wiri, just here. Okay, how are the operations carried out? Transdev Auckland have been operating the urban transport trains under contract from Auckland Transport, for which the infrastructure is owned and managed by Kiwi Rail, and Auckland Transport receives funding to subsidise these services. From 2004, Transdev offered a number of different trains. DC Loco is owned by Kiwi Rail with a push-pull mode using SA type cars, SE type cars. We'll show them in a minute. And they are ex-British Rail Mark II carriages rebuilt for suburban services. A couple of locomotives operating in push-pull mode. and some two-car DMUs. From electrification time, from 2015, there's now 57 three-car EMUs built by a Spanish company called CAF, running on all lines, except, as I said before, the Papakura-Pukekohe shuttle. And the Papakura-Pukekohe shuttle uses the two-car DMUs, diesel DMUs, until electrification is approved. So these are the vehicles that have on the left-hand side of the vehicles running at present. So the ADL stroke ADC class at the bottom are the trains that run from, they run as a shuttle. They're the diesel trains that are running. And the AM class are the brand new trains that are running on the network, from CAF. You can see the electrification and the Mark III British style electrification master in use for electrification. The SA class on the right hand side here, there's a Kiwi engine at the end, diesel engine at the end. These were based on British Mark II vehicles. And the ADB class was running from Papakura to Pukekohe, but doesn't run anymore. Okay, let's talk a bit about operations and speeds. Maximum speed categories are shown here. Speed categories range from 1 to 5. Essentially, the maximum speed for the EMUs is and rail cars is 110 kilometers an hour, which is not particularly fast, but it's fast for narrow gauge track in New Zealand. So all the rail cars are running at that speed. Speed class 5 is generally 25 kilometers an hour and includes yards and sidings. So in addition to the speed classes, you have route classifications, and that depends on the axle load and the train type, the track type, excuse me. So the classification is based on class A is the maximum axle load of 18 tons, where medium weight rail is sitting. The rail weight is generally 50 kilograms per meter. And class B is 16.3 tons and class C is less than 14.3 ton. So generally the tonnage will, the rolling stock will run at different speeds on those tonnages. So if we talk about class A traffic with speed category 1 or 2, so 110 or 70 kilometers an hour, basically the type of track is U50 kg rail with usually head hardened rail and CWR, continuously welded rail. With a choice of sleepers, there's a fair choice of sleepers. Concrete sleepers are generally the main preference, but there are considerable hardwood sleepers. There are new composite sleepers, they're plastic fiber reinforced sleepers, and timber pine sleepers as well. But timber and composite sleepers can't be installed in curves less than 400 meter radius. 300 millimeter ballast depth is the standard for category A, for class A category speed 1 or 2, with turnouts again with 50 kg rail. Excuse me. Fastenings tend to be P fastenings, P for Pandrel. They love their Pandrel fastenings, and there are some other N fastenings, but they're not elastic fastenings. Okay, so class B, clearly class B has a lower specification, so you can use long welded rails. You can have ballast depth has to be greater than 200, so it's not 300 requirement, so you can have less ballast depth, and you can have refurbished sleepers and fastenings. There is also a class B, but for street speed category 3, 4, or 5, which is even lower spec. And really you can have the ballast is still greater than 200 millimeters, but you can have a higher maximum higher percentage of foul ballast and rounded ballast as well. So generally not used in the main lines. The lowest category is lowest class C, and this can be where some rails are less than 55-pound rail, and you have mainly hardwood sleepers, and it's usually used for sidings use, apart from the new depots which tend to use higher specification materials. So in broad terms, the track is based on a track life of 400 gross tons over. So, for example, if it's 20 million tons, it will last 20 years. If it's 20 million tons a year, before replacement or cascade to minor lines. Concrete sleepers can be expected to last at least 60 years, and a lot of the track is 60 years old. The timber composite sleepers can be between 35 and 60 years, with a ballast life of between 30 and 50 years, depending on the traffic volumes and quality. These are all subject to actual conditions. Sometimes the ballast life is much less than 30 years. So typical ballast cross section in use of the main lines. Much of this has been taken from UK practice, scaled down to narrow gauge. Especially the provision of ballast shoulders. You see the ballast shoulder here, which is 100 mil high, whereas the UK we average 125 mil, and the ballast shoulder width is similar to the UK, but it's 300 millimeters wide. Depending on the track horizontal curvature, it might be 450 as well, to give some strength for CWR. The main difference between New Zealand and the UK, if you like, is the drainage. The drainage tends to be trough drainage, concrete trough drainage rather than pipe drainage on the main lines. So how is the track condition assessed? Well, Kiwi Rail maintain the track and set out the standards and codes for track inspections and condition assessment, and this is based on a colour coding system coupled to priority actions. So the colour coding ranges from green, where the asset meets the code or the standard requirements, to red, where it doesn't meet the requirements and requires immediate attention. The intervention is based on what's called the Maximo system. For example, priority 1 action, Maximo system P3 is to repair within 48 hours. The maximum priorities range from P1, which is ASAP, which is basically now, do it straight away under emergency, to P27, which is within 10 years. So as with all railways, the track condition deteriorates over time, and these photographs show some poor condition track from a long time ago, from 10, 15 years ago, which is since been repaired. And this is the sort of track that used to be on New Zealand railways when the train rails were being run down and the system was being run down. So the left-hand photograph shows a pretty severe squat in the track. The centre photograph shows some pretty poor K-type fastenings and sorry about that, go back on. Fastenings with very, very poor sleepers. And the right-hand track shows some cyclic top, which had occurred since the start of the running electrification. However, with the resurgence of the rail travel, major improvements have been made in the assessment and rectification of faults. And this is part of this work has been the assessment of temporary speed restrictions. And this chart shows the main reasons for speed restrictions, showing that formation repair is one of the highest reasons for speed restrictions. So there's a considerable amount of work required to rectify the formation and renew the track at the moment, especially considering the increasing number of traffic. The second highest reason for TSRs, temporary speed restrictions, is for rail repairs. With regard to sleeping condition, there are many types of sleepers on Auckland Railways, and these conditions are graded from 1, which is the best, to 5, which is the worst. And they range from composites, fibre reinforced, to concrete, hardwood, softwood. But the majority in pretty good condition, as this chart would show. This shows an age at the bottom, so from 0 to 60 years old, and the category from 0 to 5 on the left-hand side. So one of the worst types of sleepers in use are shown in, I'm just highlighting them in the the purple spots, which are only 10, 12 years old. And these are, they're called hardwood South American sleepers. They're sleepers that have been decayed. They were bought from Peru, I believe, and they're in very poor condition because they were susceptible to particular fungal decay after only about 10 years, and they're being replaced, but it wasn't known at the time they were susceptible to this fungal decay. So there's a big program to replace these, especially where they're in S&C. So what can be seen from the existing track? Well, since all the work has been done on the track in the last 10 years or so, there's been major improvements. So the photograph on the right shows a nice piece of track just south of Britomart, showing the new electrification, new concrete sleepers, Pandrel clips. I think they might be fast clips, these ones. But, nice ballast. And on the left-hand side, we're showing there are some Cologne egg style sleepers on top of slab track just outside Newmarket Station, which gets a lot of use. Okay, let's have a quick look at the signalling. New Zealand signalling is based on speed signalling, where the aspect of the signal tells the driver what speed to proceed at. The main signal, there's lots of different signalling systems in New Zealand, but the automatic signal rules system, which defines how signals work and how they're interpreted, runs in the Auckland network between Papakura and Swanston. So I'm not going to go through this in great detail, but the simplest system can display 3 aspects as it would: green, yellow and red. Some signals also display a 4th aspect, which is flashing yellow also in the middle. But you do have signals that show 2 heads, which can be a bit confusing. So the clear normal speed, aspects are typically described by the colour of the top head, followed by the colour of the bottom head. So green over red is for clear normal speed, but red over green is for clear medium speed, and 2 reds are stop. And there are a plethora of about another 20 different types of combinations of sleepers, which I have put on here for which are quite difficult to understand sometimes. But the new signalling on the system is ETCS level 1, European Train Control System level 1, is now in use on the new electric trains. This is the first installation in the Southern Hemisphere, I believe. And the contract was awarded to Siemens in 2009, with the first use on the electric service in 2014 when they were doing trial running. This uses Belize's placed in the track linked to signals to transmit route data. I spent some time traveling in some of the test trains, and one of the issues with the signalling was that the ETCS braking was almost too good. The ETCS braking braked earlier than the driver would have braked. So there was a lot of tolerance in the braking distance, and there was some issues with the timetable being met, but that's since been resolved. Have a quick look on electrification of the system. All 4 suburban lines between Swanston in the west and Papakura in the south. So you have Swanston and the rest up here. Papakura is south. Papakura is just here, then Pukekohe in the south. But to Papakura is the end of the electrification. They're all electrified to 25 kV AC, which is the same voltage as the North Island main trunk between Auckland and Hamilton. And Palmerston North. And to contrast that, the Wellington suburban network, which is the capital city further south in North Island, uses 1500 volts DC. The Onehunga line, which the line just here, was the first line to be commissioned after it was reopened after it had been mothballed, and it's supplied by two connections to the company Transpower's national grid, the 220 kilovolt national grid. Both connections are duplicated, and one connection can supply the entire network if the other one fails, creating a high level of redundancy. I understand that Kiwi Rail has said that electrification would use less than 1% of Auckland's electricity supply, so there's plenty of supply. So the electrification is on the main trunk, the North Auckland line, the Newmarket section, Onehunga line, and the Manukau line. And it consists of a simple feeder type with 3 conductors in the OLE, contact wire of copper and an earth wire. The current to the EMUs travel through the catenary and contact wires, with a return current travelling through the rails, the earth wire and the body of the earth. And it's mounted on steel masts or portal structures using UK type Mark 3B cantilevers. So the typical one is shown here. So this shows the diesel train next to the new AT train. Diesel train next to the new AT train with the OLE cantilevers. Okay, let's talk a bit about rolling stock. We talked a bit about the early rolling stock on the tramways. This is one of the old style diesel rolling stock, which was replaced with a new electric stock in 2015. The old diesel EMUs were shipped for use in Mozambique, so this is being shipped out to Mozambique back in 2014, I think this was. And these are some of the views of the new trains in use. So 2 trains here in the rolling stock depot at Wiri, waiting to be sent out. The bottom right photo is one of the testing photos took while they were testing the trains, and they put sandbags on weighing 20 stones each, I think it was. I can't remember how many kilograms it was. But they basically filled the train up with sandbags to do test running. Bottom left are the details of the cab, which is a very simplistic cab with ETCS running on it. It's the guy's driving in the center of the train, and very simple layout and nice and tidy. And the top left photograph shows the inside of the train. There's a separate floor to drop down into the 2 different floor levels, but it's a nice clean train. Okay, with regards to the new fleet, as I said before, there were 57 3-car sets manufactured by CAF, Construcciones y Accesorios Ferrocarriles. And the contract expires for their maintenance in 2025, and the first trains commenced 2014. And even when they started running, it was realised that they wanted to extend the trains because of the amount of people running on the trains. So when the new loop runs, the rail link runs, which I'll talk about a bit later, they're going to be needing 72 3-car sets by 2021. That may be 2022 or 2023 now because of COVID issues delaying the actual works. Okay, we talked earlier about patronage growth. I'm going to talk a bit more about it since the year 2000. Britomart station opened in July 2003, and the number of people travelling was about 3 million people travelling. The first EME revenue services in 2014, the actual number of people travelling increased to about 10 million. And then the latest figure for 2018 is over 20 million. And the future, with the extension south to Pukekohe from Papakura in 2025, that's expected to extend to about 30 million. This is a lot more than was originally envisaged. In 2014, when the electric train started running, the Ministry of Transport expected patronage to not to be more than about 20 million trips before 2020, but the actual was the 20 million trips was actually reached in 2016, so it was reached 4 years ahead of the expected government target. So that resulted in the need to extend the number of trains or do some changes to the track system and the network, which resulted in some investment pipelines coming into use. So these investment pipelines ended up being as follows: the third main line along the North Island main trunk road from Wiri to Key Park in the centre of town, the Papakura to Pukekohe electrification, which I talked about before, catching up on the renewals programs to improve the network resilience, because the size of the Kiwi network, the Kiwi Rail maintenance network, was insufficient and needed to be increased, so they could actually improve the network resilience. Improvements in renewals and maintenance, and the new Auckland Train Control Centre. Those are the main investment priorities. In addition to that, there was also work outside the railway, if you like, to address congestion, and that included level crossings. There are lots and lots of level crossings on the railway, and to manage the safety risks, a lot of level crossings will need to be changed to bridges, and also some of the level crossings tend not to have gates for passengers. They have a gate for traffic, but there isn't a gate for passengers. Although it is possible to go around the barrier to cross the railway. So a lot of gates have to be put in, pedestrian level crossing gates put in. In addition, Britomart East remodelling is going to be done to take into account the fact that Britomart is now going from a terminus station to a through station. So future opportunities were also in the investment pipeline. It's a bit difficult to read this, I'm afraid, sorry about that, but so that included increased platform capacity, so for 9-car units. So one of the changes as a result of the increase in passenger numbers is to increase the car units from 6 to 9, and to allow passive provision for future 9-car units for the future rail investment projects. Also to improve ceiling capacity and traction system resilience. There are also proposals to enhance the Hamilton to Auckland service to increase the speed of trains and provide extra traffic capacity. So I'd like to talk a bit about what the investment pipeline is and what is proposed for the future. The largest transport project ever undertaken in New Zealand is now taking place, and that is the City Rail Link underground railway from Britomart to Mount Eden, which doubles existing rail network capacity. It's only 3.5 kilometre long twin tunnel, but it will double the existing rail capacity because it essentially provides a loop and a through terminus for Britomart station and provide two-way running. So at the moment, the network coverage, you have essentially the 20 trains per hour from out of Britomart. You have along the main line, there are 6 trains to Manukau, 6 trains per hour to Papakura, 3 trains an hour to Pukekohe, 2 trains an hour to Onehunga, and 6 trains an hour to Swanson. That will be increased with the new loop. The new loop is, as you can see from Britomart, is a new loop that goes around to Mount Eden. That increases the capacity of Britomart to 24 trains per hour and 24 trains per hour towards Swanson. Increases 6 trains per hour to Manukau, 6 trains per hour to Onehunga, and 6 trains per hour to Papakura. Considering 6 trains an hour to Onehunga and 6 in the peak and 3 in the non-peak, is a considerable improvement considering the Onehunga branch was mothballed in 1973 and now it's back in use. So what's the horizontal alignment? Essentially the alignments, if I said before Rangitoto Island, this is Rangitoto Volcano in the distance. So this is the main bay. Auckland Central Business District is in here. The Britomart station is highlighted in the top left of the drawing here, with the existing railway comes along here, or there are 2 ways out of Britomart. Then it's another junction to Newmarket and then back along to the western route. And some trains that go from Britomart to Swanson have to go along from Britomart to Newmarket, run round and then back again. So there's no direct route. The new loop will provide stations at Aotea, Karangahape, and a new station at Mount Eden. So there'll be a new triangle to be able to allow you to have circular running and different running characteristics, operational characteristics, which will improve the number of trains. So following completion of the CRL, Britomart will no longer be a terminal station. There'll be 2 through platforms, while 3 will be terminal. Mount Eden station will be developed. There'll be new stations in Wellesley Street, which is one of the main streets in town, Aotea, and at Karangahape. It's going to be proposed to be completed in 2024, but there's nothing been done much this year due to COVID, so that's affecting the date. But at least it will mean that Britomart is no longer a terminus but a through station. It's funded by New Zealand Government and Auckland Council. City Rail Link came into being in 2017. It was going to cost 3.4 billion, but it was increased at 4.42 because, as I've said, they've increased because of the increased patronage. They've increased the length of trains, length of platforms, and provide passive provision. So vertical alignment is pretty steep. This isn't the scale, but the vertical alignment's about maximum gradient. It's about 1 in 30. And you have the main Britomart station running directly up to the existing line at Mount Eden. With Mount Eden station is an existing station. It's closed at the moment for redevelopment, but that will be upgraded. And there'll be 2 new stations at Aotea and at Karangahape. And Britomart station, as I say, will be extended. It will be punched through to provide a through station. So the 1 kilometre section from Britomart to the new Aotea station is currently under construction. This bit's under construction, and part of the early works for Britomart have been completed along Albert using cut and cover tunnelling. The first stage of the work launched on July 24th in 2018, and started digging under Britomart Station's CPO building, the Chief Post Office building, which is by Britomart Station. And a single 25-metre wide trench will be excavated in this area. So next one. Okay, from Britomart, there'll be underground in twin tunnels, and the TBM for the railway was delivered early December last year, and there was a naming ceremony for the TBM, and it was named after a lady called Fina Cooper, who's a Maori activist essentially. And this will be used to excavate 2 1.6 kilometre tunnels from Mount Eden to Britomart. So we'll start from Mount Eden, go to Britomart, and then start back again. Diameter of 7.15 metres. To compare that, an adult giraffe is 6 metres tall. It's a weight of 910 tonnes, equivalent to 9 blue whales, and it's 130 metre long, which is longer than a rugby pitch. And tunnelling was due to commence in April 2021, but it's only just been delivered, so COVID may affect what happens next year. But it's programmed to take 9 months for each tunnel, a maximum 30 2 metres a day. So this diagram shows the Mount Eden station is at the bottom here, and the tunnel route, basically the 2 twin tunnels, go around towards Karangahape station and then Aotea station and then on to Britomart station. This is a bit of a busy diagram, but shows the 2 tunnels side by side with 130 mil cant, which is the maximum cant used on the railways. Very tight for electrification clearance at the top. As I say, a typical cross section of TBM. There are a number of contracts for the CRL. 2 of them are for early contract involvement. The first one is to establish temporary accommodation to the Britomart season ticketing. So Britomart station was closed down, and a new entrance and ticketing section opened up, so the existing station could be used while they were rebuilding parts of the station. A lot of enabling works concerning stormwater drains and strengthening the sewers in contract 2. The contract 3, which is just about to start, is the excavation of the 2 tunnels. It's 2.2 kilometres long, includes 1.6 kilometres of the main tunnels plus the both ends, the TPMs at both ends. And contract 3 also includes the construction of Aotearoa and Karangahape stations. And other contracts from C5 to C9 include the Western Line remodelling, a lot of remodelling with OLE and the signalling, new footbridges at Mount Eden, stormwater diversions, track installations, wider networks and works, and the Britomart East Junction modifications. So as a summary, C1, C2, and have been awarded already, and that's under construction. C3 stations and tunnels are just about to start, hopefully with COVID. That should start as early as possible, but COVID may delay that for a few months. There was no C4 for some reason. C5 is work on the Western Line. C6 was further work to upgrade sewers. And C7 was a systems integration, with C8 and C9 working on Britomart East later on in the programme. So this is a cross-section of Aotearoa Station, which is cut and cover station, 50 metres deep under Albert Street, and it will be 300 metres long, running between Victoria Street and Wellesley Street. So they're the main streets in Auckland, running north-south. Karangahape is a bit deeper. It's 32 metres underground. Originally there were plans for 150 metres, but now they're going to be extended to 300 for reasons I've stated before, because of the increase in number of passengers. So they're going to be lengthened, and demolition of buildings on Mercury Lane for the 2 ends of the station began in November 2019, and demolition of the overall sites is expected to be completed next year. So there's a lot of work that's been delayed due to COVID that hopefully will be brought back on track. So this is a cross section through Karangahape Station. So you can see on the right hand side, these are escalators going down into the platforms, and on the left hand side you can see that's where the escalators are here. So you've got a wide platform with station buildings and a considerable amount of oversight development as well in this area. It's a very constricted area. And the final station, this is not a new station, but this is Mount Eden Station on the existing North London Line route. So you've got North London Line platforms on the left-hand side, and the station building, and the new station will be in cut and covered construction. Demolition of the existing station has taken place, so there's no station there at the moment. So that will allow for the new CRL platforms to be constructed. Okay, other rail projects coming up. In 2019, Jacinda Ardern allowed funding for a number of rail projects. As I've said before, the $350 million for improvements between Wiri and Key Park Corridor. So a third rail line to ease the bottleneck, and that third rail line will essentially be used by a lot of freight traffic, because there is a lot of freight traffic still running through, but it will allow passenger traffic to run better when the freight traffic's out of the way. And there'll be additional capacity around Westfield Junction, which is the southern junction between the Eastern Line and the main line. Also, it was announced that 371 million New Zealand dollars will extend electrification from Papakura to Pukekohe. So that's 19 kilometres of electrification. And that will mean you can get rid of the old diesel trains, and all the passenger trains will be electric. So what other proposals are there in the area? Auckland Transport Plan over a 10-year period, 2015-2025, include a policy to allow for a light rail network. So studies are underway at the moment to determine the feasibility of the light rail network. So there is a fund to try and finance this, and 2 networks, one to the south and one to the west, by 2028. In the meantime, Auckland Council the government received a proposal from the New Zealand Super Fund and Canadian Pension Fund to assess the viability of Auckland Light Rail project for commercial investment. So that's without any prompting from anybody. So they obviously think it's a good idea. And the idea basically was to have a procurement, that they've launched a procurement process for one railway running 22 kilometres south, so from Britomart, city centre Britomart, to Mangere, connecting Queen Street, Mount Roskill, and then Onehunga. So you've got the existing railway line to Onehunga as well. This is the light rail, and then on to Auckland Airport. At the moment, it can take a long time to get from Auckland Airport to the centre of town. There's buses only, there's no railway. It can take, because the buses tend to stop at lots of places, and even if you get a quick bus, they stop at all the hotels. So it can take an hour and a quarter to get to do a short distance, 22 kilometres. So this would speed up those journeys. The other alternative light rail proposal is a route that follows Highway 16 between Britomart city centre and then on to Karangahape across to the west. Okay, and the final proposal, which the Green Party have been looking at in earnest. They've been looking at it for the last few years, but last year they looked at it in more detail. In 2017, the Regional Rapid Rail Initiative was proposed, including tilt trains with an maximum speed of 160 kilometres an hour. And this network would provide passenger services from Auckland through to Hamilton, Tauranga and Rotorua. At the moment, the Auckland to Hamilton line is electrified, same as the Auckland Electrification, 25 kilovolts. But Tauranga and Rotorua is not electrified. So that's a proposal. Whether that will come off the ground, it'll be interesting if it does come off the ground. Hamilton is a large city, but it would be better if it was be able to connect all the way to Wellington. However, Wellington is 1500 DC electrification, so that could cause some issues as well. Okay, and with that concludes my presentation. Any questions? How do I see any questions?
Thank you very much, Matthew.
Shall I unshare? Stop sharing.
You know, you can leave it on if you wish. You can. It's entirely up to you. If you wish to unshare, then you can see your face a lot more. If you wish to have your face as a small camera, you're welcome to leave that shared. Really, it's entirely up to you.
I wanted to see, how do I see the questions?
If you open the chat function, they're all in there, but I'm going to ask them directly to you anyway on behalf of everybody else. So, your first question, I have a grand total at the moment of 1 question in the chat.
Okay,
I have 3 questions of my own, which I will come back to. But the first question comes from Constantine Collias, and he says, "What is the job market in New Zealand like?"
You fancy going? Job market is they are crying out for signalling engineers, electrification engineers, and they are crying out for construction people. One of the issues with New Zealand is it's close to Australia, and Australia pays a lot more money, so a lot of people leave New Zealand to work in Australia, and sometimes they even live in New Zealand and travel to Australia and come back at the weekends. So there is a big job market in a big resource requirement in New Zealand, especially on the railways. How easy it is to get into New Zealand at the moment is another point, because that's not easy. I think if you are living in Australia or you've been there for a few weeks or months or whatever, then you can get to New Zealand a bit easier. They've just opened it up, but otherwise it's quite difficult to work there at the moment because of COVID.
naturally. Cool. Thank you very much. Right, I'm going to ask a question of my own, if you don't mind.
Yes, please. Yeah.
I've got a few. I have a particular interest in slab track, so my eyes pricked up very much when you shared that picture of Newmarket Station. So what's the ratio? Obviously, it's an awful lot of renewals and upgrades and things have been taking place. So what sort of ratio have you got between standard ballasted track and slab track? Is it specialist junctions? Is it just tunnels? Is it particular key areas, or was there a preference there?
I don't know the ratio exactly. I could find that and let you know, but it is generally only in the Britomart area, in the tunnels and Newmarket junction. There aren't many tunnels anywhere. There's a tunnel at west of Swanson which isn't slab track and it's going to be slabbed. The track in Britomart is only in the platforms is it slab, and the rest of it is ballasted track. And the only concrete slab track is the one I showed you at Newmarket, and it's a double junction. It's not double junction. It is a double junction. It's a triangle, in fact. So it's got a funny diamond in there that gets battered all the time. So there's not an awful lot. They could do with having a lot more. And they could do with the tunnel construction will be slab track for the new Crossrail link. But they could do with having slab track in some of the other tunnels on the extents of the system. The one in Newmarket has been there quite a while. It's been there probably 20 years now. I mean, it's got they look like Cologne eggs, but I think they're a Chinese copy. as is a lot of the railway components are from China. Certainly the S&C.
Cool. Right. Thank you very much. On to some questions. There's some questions coming in. So I've got one from Hashim Ahmed. What is the ruling gradient of LCR?
I believe it's 1 in 50. Again, I could find that out, but I don't know it off the top of my head. But the steepest is 1 in 30.
Cool. Thank you. Next one from Michael James. The 25 kV electrification in the proposed tunnels looks to have very tight tolerances. How is flashover risk managed?
I'm not an electrification engineer, so I could have to find that out for you, but it is tight. I have to say it is very tight. So I can't answer that directly, but I will find out and come back to you on that.
Okay, fair enough. Next one from Konstantin Kogias again. Sorry if it was mentioned already, believe it wasn't. What is the stress-free temperature in New Zealand, and is it being considered to be updated like in the UK?
That's a good question. That's a very good question. I think it's 40 degrees. The reason I say it's 40 degrees is because above 40 degrees they have a special system for inspecting the track, and they called them stress 40 conditions. So when it gets to that temperature, then they have to get people out. But it's between 30 and 40 degrees. I wasn't aware it was being reconsidered in the UK. What's it being considered in the UK? Do you know, Phil? It's going to be raised.
From personal experience, yes, there's been rumblings over the last few years of we shouldn't. There's been a variety of different people say it's probably time to raise it by at least 1 or 2 degrees. Yeah. I'm guessing that's what Constantine's referring. I don't think there's any firm proposal to do it yet, but there's been a fair amount of discussion, talking proposed draft standards. Maybe we should, maybe we shouldn't. Discussions, forums, etc. So there's definitely a wind of change in the industry. Yeah. Okay, Constantine has just put another comment in there, so I'm going to respond on that. He says it's 27 degrees currently, obviously. Due to the recent heat waves, it's been talked about revisiting it.
Yeah, I knew it was 27. I didn't realise it was going to go up or not. Yeah, I wouldn't be surprised. Thank you, Constantine.
Okay, next question comes from Paul Ebbett. So he says, I assume tunnel and structures design takes account of seismic action.
I assume it does as well, but I haven't been, I don't know much about the structures, I'm afraid. The seismic action is surprising. Although it's all volcanic, the tectonic plates are away from North Island, and there's more seismic action to in the South Island and the southern part of North Island. So the Britomart tunnel and the new tunnel will take into account seismic action. Again, I could find out how it's being done. It will take into account. It's part of the standards and codes requirements for New Zealand.
Awesome, cool. Thank you very much. Next question from Hashim Ahmed. Why is the change from timber to concrete sleepers, knowing that there in Australia is famous for good quality hardwood, Jarrah and Karri?
Jarrah and Karri, yes, I know that. But Jarrah and Karri are the indigenous species, if you like, of New Zealand. But they also the preference is to use concrete because it lasts longer. I know Jarrah and Karri can last a long time, but they tend not to have that sort of hardwood sleepers out there. I can't remember what it's called out there, but they have a lot of what's called TPR, treated pine wood sleepers, and they're bringing on a lot of fibre reinforced sleepers, the new plastic, but it's not plastic sleepers, but they're FFUs, I think they're called. They're trying to produce some of those, and they've got a similar rubberized sleeper that they're using in their S&C, which is very light and very easy to use.
Interesting. I know we're looking at FFU sleepers and have been for many years in this country, and we've got a few trials out there, but it's one thing I'm pressing for myself actually, to try and get them fully certified so we can start using them a bit more than just the odd trial here and there.
I think they're using trials in bridges. They tend to in Network Rail, don't they? Not on S&C. They use on Hong Kong.
You've got the Newark Flat Junction was done in FFU.
That was one. Yeah.
Okay.
One of the main issues with timber is that they bought a load of timber sleepers from Peru, which are rotting after about 5 to 8 years. They've got fungal decay, and I think they bought them on the cheap, and now they're trying to replace them all. And with more trains running, it's much more difficult to do any work, as we all know.
Definitely standard thing that a lot of organisations repeat, isn't it? Buy the cheapest and then pay the price for years. Okay, thank you. Move on to another question from my good self again, if you don't mind. Notable there was quite a strong UK influence in some of the design choices and things. So partly to do with the standards, do New Zealand have a good set of their own standards, or was it mostly using UK standards? How do TSIs come in there? Just be interested to know a bit more about what level of standards, and was it? I presume it was UK design consultancies doing a fair amount of the work on the designs and things, and therefore
I think you'll find that a lot of the people they are redoing all their standards at the moment. They're calling them principles and standards. They used to call them codes. There was a signalling code, electrification code, and the track code, and that's what everybody used because it was mainly based on a freight railway. Now they're improving their standards, and the people who are doing the improving to the standards are people who've emigrated from the UK over to New Zealand, it seems to me, because they all seem to be either ex-BR or ex-Network Rail people who are in charge of the standards, and standards are run from Wellington, and there's a big office in Wellington that deal with all the standards. But they are, you are right, they are very, very aligned with UK standards, but based on the 346 railway. So there's a lot of similarity with Australian standards as well, because a lot of there's 346 in Australia.
Yeah. Okay, and in a follow-up, of course, I noticed the use of UK OLE system and European train control system, and so again, as part of that same influences, that's the technology they're familiar with, I'm assuming, which is the overall overriding issue. So,
they're very proud of the fact that they're supposed to be the first ETCS level 1 in the Southern Hemisphere. That's what they said anyway. I can't think of any others at the moment. It's mainly Northern Hemisphere, aren't they? But but it was interesting the issues they had with the braking. When I was with the drivers wanted to brake later than the ETCS was allowing them to in the test running. So they were taking too long to get to a signal, to brake at a red signal. The drivers reckon they could brake quicker because they knew their territory better than the ETCS knew its territory, if you like.
Difference between a computer model can be the best thing in the world, but
but if the tolerances are too wide, then you can, it can be better. But I think they've solved that anyway. There were some big problems on the opening day of trains running late, which is a bit of an embarrassment to the government.
Okay, right. Thank you for that. Next question comes from Robert Bennett. He says, why are they removing the Siemens ETCS on board?
Replacing with the CAF system because there were issues with the Siemens system, resonance issues. But I'm not a civil engineer, so I can't explain it in more detail. But that's that was the reason. So there was some problems with the interface with the CAF train. So CAF have decided to use their system, or they decided to use CAF's system. That was the reason.
Cool. Okay, thank you. Next question comes from Rodney Pinchin. You mentioned freight.
Yes.
I was expecting you to say hello, Rodney. There, at a point.
Hello, Rodney.
You mentioned freight traffic, about which you might have some historic knowledge on the Thames Valley Railway here at home. What freight traffic runs in North Island?
There's container traffic mainly. It's from the ports. There's a lot of container traffic from the ports. I don't think I've seen any other traffic running on that railway while I was out there. There's obviously engineering trains and everything that run a lot, but it's mainly container traffic, cars and small parts, that sort of thing. There aren't really any heavy iron ore or anything like that. I don't recall seeing any heavy traffic, any coal trains, anything like that. Mainly freight, mainly container traffic.
Okay.
Thank you, Rodney.
That's the last question I've got in the chat. I've got one more from myself, which I will go to, but I will before I ask that, one last invite to anyone else. If you've got any questions that you'd like, then obviously that's it in the chat. So I'll draw it to a close after my question. If last chance to have any burning issues, put them in now, please. So mine's a fairly quick one. You mentioned there was part cut and cover tunneling and part tunnel boring machine tunneling.
Yeah.
Obviously, cut and cover, in particularly a built-up area like that, is difficult. I'm guessing it follows roads and curves and things. Was the cut and cover just a small section in a detailed area, and the TBM did the most, or was it what kind of
cut and cover? Well, the main cut and cover bit was at the new station at Mount Eden, which is beside the existing station, which was closed. So that's cut and cover. Otherwise, you have the cut and cover for the actual station construction for Aotea station and the Karangahape station. So they've been, basically the roads are closed, the cut and cover put in, and then the train, the boring machine meets them. So they're only short sections of cut and cover.
Okay, right. Thank you very much. So I have no further questions. I have no further questions in the chat. No one's asked to either, so I'm going to draw it to a close there. Okay. Matthew, thank you very much. I'm going to pass.
Is there any questions? If there are any questions I've been able to answer, is there any way of sending me those questions and I can respond to them?
Yeah, sure. Yeah, I can copy out the text from here. I'll email it to you.
Yeah, can you do that? So that'd be then I can.
Yeah, no problem. I'll do that for you now. No worries.
Okay.
Okay, right. So moving on, I'd like to invite Mick James from the IMechE to propose a vote of thanks, please. Thank you, Mick.
Thank you. Hi, Matthew. Thank you very, very much for your talk, which unbelievable. A railway that actually couldn't be further away from us is so remarkably similar to our own.
Yeah.
Even including it mirrors the GB growth pattern from Millennium. So it's remarkable. The gauges was an interesting discussion as to why we went from 16 to 1435 and then even down to the 3'6" or 1067. But there you are. It just goes to show that gauging has been a problem worldwide forever. I have to say I'm glad I'm not a driver on New Zealand Railway. That signalling confused me completely.
I didn't show all the signals.
Which is the threat that you gave us, that because you only showed us the red and green with the double head. Even that was frightening. Very noticeable. You said the experience with ETCS, the braking was very pessimistic. and that mirrors the experience already gained in Europe, in Holland, where exactly the same thing happened. And indeed, drivers of freight trains cheated and told the loco that they were driving a passenger train in order to get the braking back under control again. So yeah, it looks as if that's a problem which doubtless will be sorted out. It's great that it's obviously very Europeanized, and the CAF seems to be doing very well in New Zealand. They're doing increasingly well in this country as well.
Yep.
The one thing I did notice was the standard unit of measurement in New Zealand is different to here. Here, the London bus and the football pitch appears to have been replaced by the blue rail in the rugby pitch, but as a standard unit of measurement. But Matthew, thank you very, very much indeed for an incredibly entertaining talk, and the time just disappeared completely. So at this point, I would normally ask for a round of applause, and you'd be deafened by the applause. But we have to do that virtually and sort of pretend
Raise
that
your
you
hands.
can hear us all clapping.
You've got to unmic and then clap.
Yeah, some other sections I've heard. If you could turn your mics off,
Turn your mics back on, then you can give me a clap.
Yeah, we can all give you a clap.
Thank you very much.
There we go. Thank you very much. Right.